So one of the things that that comes up quite often in Newton graphs is really critical points, and the critical points, some of them that can come up really quite often in graphs is the y-intercept, the x-intercepts, and whether set point is somewhere on the line. Now, really, there's two ways they can give this to you. The drawing could be there, right? Let's say they gave you the equation, you've already drawn it. Then things are really quite easy, okay? So let's say the y-intercept. Now y-intercept, we're doing the red line first, okay? Ignore the blue line for now. No blue line. We're only looking at the red line, okay? If we look at the y-intercept, it's where that red line crosses the y-axis. Now you tell me, is this the y-axis or is that the y-axis? That, my friends, is the y-axis, okay? So I go across that red line till I hit the y-axis, and I see that it hits on 5. So I see that the y-intercept is in when y equals 5. That's all good if they ask for the y-intercept. You can write y equals 5. But if they asked what are the coordinates of the y-intercept, which is very often the case in a graphs test, you should write you should write the answer as coordinates, right? Which is 0, 5. Now, let's say you want to find the x-intercept, right? Once again, we just see when does the red line cross with the x-axis? Well, I'm going to follow the red line and, ooh, it hits the x-axis over there. That's quite hard to do visually. Why don't we leave that till we get to doing it with algebra? That's quite hard to do visually. Okay, and finally, is negative 2, 3 on the line? Well, if we go negative 2 and up 3, we can see it's not on the line. So this is visually, and visually is really a piece of cake, and really for year 10s, I mean, finding the y-intercept, geez, and the x-intercept should be a piece of cake. A little more interesting, really, is when we do it without the drawing. So let's say in a question, we have not been given this graph, we have not been asked to draw it. All we're given is this right here. None of this. The only reason I'm leaving this here is to show you that it works. Okay? But really, you're only given this, and now you have to find the y-intercept, the x-intercept. You have to find out whether this is on the line, and all you have is that equation right there. Now, algebraically, if you want to find the y-intercept, you set x equal to 0. You want to find the x-intercept, you set y equal to 0. It's the opposite letter. You set the opposite letter equal to 0, okay? So firstly, let's say the y-intercept. You make x into 0. X is 0. So if x is 0, I can just write 0 wherever I see an x. Okay? Now, all you have to do is rewrite this. And everywhere you see an x, put a 0 with brackets. Okay? Now, you tell me something. Is that an x? Nope. Is that an x? Nope. What about that? Nope. This? Yes. So this over here needs to become a 0. What about that? No. So if we write it out, we'll write y equals 2x plus 5. I mean, really, if you should be able to read your answer, and wherever you see a 0, if you say x, you're saying the equation. If I reread this, and instead of 0 I said x, what would it read? Y equals 2x plus 5. Y equals 2x plus... It's the same thing, right? All you've done is you made... Wherever you saw an x, you wrote a 0, right? And we throw that in our trusted calculator, and we get out the other side, 5. Now, as I said before, so you found out that the answers are x equals 0 and y equals 5, okay? And we have to, often we have to write it as coordinates, so we'll just make sure we write it x and y, okay? A little more interesting is when we got to find the x-intercept, okay? And to find the x-intercept, you set the other letter equal to 0. So to find x, we set y equal to 0, okay? Now the x-intercept, I'm just going to take wherever I see a y. So not here, not here, not here. Here, I'm going to write a 0 there. So if I write a 0 there, I get 0 equals 2x plus 5. You see, if I reread it again, with a y wherever I see a 0, it says y y equals 2x plus 5. That's exactly what I had in the first place. Just written that 0 where I see the y. Okay, now this is a little more challenging because it's not just going to spit out. You're going to have to do algebra. What do I get rid of first, the 2 or the 5? Well, hopefully, being this close to exams, you know that it's the 5 we get rid of first. So we minus 5 from both sides. But since I did it to the right, do it to the left. Okay, so I'll get, there should be a 5. I get 2x equals negative 5. And the next thing I want to get rid of, I want to erase, is that 2, right? Be careful, that 2 is multiplying the x, so what do I got to do? I got to divide by 2. But since I did it to the right, I'm going to do it to the left. And so I get x, which is negative 5 over 2. Your calculator may have spit out negative 2.5. No problem with that. They're the same thing. Okay? And now, if you can just make sure you write out x and y, because usually you will have to write out coordinates, right? Now, be very careful. You might, because you got the 0 first, you might want to write 0 here and then negative 5 over 2, but this is the wrong order. X comes first and then y. A simple way of remembering the order when you do this, let me just get, a simple way of remembering the order when you do this is if you remember the ABC song. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and then Z. So if X is first and then Y in the ABC song, X is first and then Y when we do our coordinates. This is rubbish. This is wrong. The answer is negative 5 over 2, 0. Right. Now, here is the most interesting question. Is negative 2, 3 on the line? And what we know from our graph, our understanding graphs, is if you put in x into the equation, it should spit out y, right? Any x, if you put it in this equation, it'll spit out the corresponding y that belongs on the line. So what is my x here? Is it 3? Nope. What about negative 2? Yep. So what I'm going to do is I'm going to substitute x equals negative 2. I'm going to pick up the negative 2 and I'm going to write it wherever I see an x in here. Well, let's look at the equation. It says y equals 2x, but wait, x is negative 2, negative 2 plus 5. Don't forget the brackets, otherwise your calculator won't know how to do it. Okay, and if you do some, put in your calculator now, you get 1. So actually, negative 2, 1 is on the line, right? When x equals negative 2, y equals 1. So negative 2, 1 is on the line. So is negative 2, 3 on the line? No, it's not on the line, right? And just to confirm everything we found that the y-intercept was 0, 5. Well, you can see it right there. We found that the x-intercept was negative 5 over 2, negative 2.50. That looks about right over there. And when we were looking at negative 2, 3, which is not on the line, we found that no, negative 2, 1 is on the line. So as you can see, it all really does work. You just have to remember that to find the y-intercept, you set x equal to 0. X-intercept, set y equal to 0. And to find a point on the line, just put in the x and see if you get the y, right? So let's look at the blue equation now. Let's look at the blue equation right there. Now, at the very amateur level, let's say you've already drawn this line. You've been given this line and you know how to draw it because it's a straight line and you know your y equals mx plus c. And now they ask you to find y-intercept, x-intercept, and if is that on the line. Can I please insist that you find y-intercept as coordinates, x-intercept as coordinate, and just answer yes or no. Let's do it visually first because that's really at the easy level. Try to do that. Okay, so these are the answers. As you can see, um, if we look at it, we can see that the y-intercept is over here. And amazingly enough, the x-intercept is in exactly the same place. Don't worry about that, man. So it's got the same x and y-intercept. And is negative 1, 3 on the line? Well, if we go 1 across and 3 up. Remember, we go across the corridor and then up the stairs, right? So we go across the corridor and then up the stairs. And then we put the point over there. So yes, very much so that is on the line. Very easy. Easy. Now let's... Right. So if we have to do this algebraically, remember to find the y-intercept, set x equals 0. Alright, so I'm just going to rewrite my equation. Y equals negative 3x, but I'm just going to write a 0 instead. And that gives me 0. So, when x equals 0, y equals 0. So I get the coordinates 0, 0. Right? If I want to find the x-intercept, I make y equal to 0. Right? So I'm going to look at my equation, and I'm going to write 0 equals negative 3x. Sometimes students get intimidated by an equation whose answer is 0. Don't worry about it. Just stick to your basics. Divide by negative 3. But since I did it to the right, do it to the left, and I get x equals 0. Don't worry about that. That's fine. Write out your coordinates. X first, and then y, as in our ABC song. And finally, is negative 1, 3 on the line? Well, I know x is negative 1, so I'm going to make x into negative 1 over there. And I'm going to get, when x equals negative 1, y equals negative 3x. And if I put that in my calculator, that means that y equals 3. So when x equals negative 1, y equals 3, if I put that into coordinates, remembering my coordinates go x, y, z, negative 1 and then 3, so I can see that those two are the same. Therefore, yes, negative 1, 3 is on the line. Okay, so first things first, we're going to do the red line. So please pause this, but the instructions are for the red line. Can you please find the y-intercept, the x-intercept, and whether this point is on the line? So first, just for practice, do it visually, and then really the real question at year 10 is, can you do it if this was not given to you? Can you do it with just an algebraic equation? So press pause right now, and then I'll talk you through it. Okay, so to find the y-intercept, I set x equal to 0. Remember the other letter equal to 0. So I'm going to make x in there equal to 0. So I'm going to set x equal to 0. So I get y equals negative a half x, which is now 0, plus 2. Okay, and there's no need to solve that. It's already y equals. So I just put it in my calculator, and it tells me that y equals 2. Very good. So I basically got when x equals 0, y equals 2. If my question requires it as a coordinate, make sure I put the x value first and then the y value, right? And that's my answer. The x-intercept, always a little more fruity, the x-intercept question. I just make y into 0, okay? So I'll write it out again. I got 0 equals negative a half x plus 2. So I've essentially just made the y at the beginning into a 0. And as you can see, it's always more challenging to find the x-intercepts. You got to solve basically, and I'll minus 2 from both sides because you should be at that level that you know that's what you do first. And negative a half x equals negative 2. And at this point, you'd probably times by negative 2, but if you really want to, you can divide by negative a half if you want to stick to your processes. Divide by negative a half, and you'll get x equals, put it in your calculator, negative 2 divided by negative a half is positive 4. My bad. Okay, so basically that's the x-intercept, x equals 4, but we don't want to write it as x equals 4. We want to write it as coordinates because that's usually what's required on the test. So I put my x value first, which is 4, and my y value, which at the beginning we said we're going to set y equal to 0. So just put 0 in there. And that's my x-intercept. And then finally, is the point 2, 2 on the line? Well, I always put that x in and see if that y spits out. So I'm going to substitute x equals 2. Okay, so I'm going to look at my equation. It says y equals negative a half x. Ooh, seen the x now. Better write the other thing. Better write the 2 plus 2. And I put that in my calculator, and I'll get 1. Okay, so basically that says the point x first and then y. That point is on the line, so no. Please don't just write no on the test. I'm doing that because I've got this this silly stylus thing that's very hard to write with. You would write no, the point is not on the line, etc., stuff like that. And just to further my point, to just make sure to show you that it works, the y-intercept for the wait. Oh, sorry, that equation is in red, but it's actually the equation for the blue line. My apologies. It is the equation for the blue line. I can confirm that. Sorry. But if you can look at the blue line, you'll see that the y-intercept should be 0, 2. 0 cross 2. Yep, that looks good. The x-intercept should be 4, 0. 4 cross and 0 up. And is 2, 2 on the line? Well, no, it's definitely not on that blue line. So now your turn again. Can you please work out the y-intercept, x-intercept, and if that point is on the line for this line over here? Give you some time. Pause it. Do it visually, but then, of course, the real money is if you can do it algebraically. Pause now. Okay. So if we look at this equation over here, we're going to find the y-intercept. We do that by setting x equal to 0. So we get y equals 2x minus 3. See how seamless that is for me? I just say 2x minus 3, but I really write as 0. Okay? And put that in my calculator because that's all I have to do, and I get negative 3. Okay? And so when y equals 0, x equals... Sorry. Go back there. Put that in the wrong order. When x equals 0, y equals negative 3, and as coordinates that would be x first. And then y, for the x-intercept, I set y equal to 0, so I'll write y equals 2x minus 3. Make sure I plus 3 to both sides, and I'll get 2x equals 3, and divide by 2, I get x equals 1.5, right? So I find that when y equals 0, I get x equals 1.5, but be very careful when you write your coordinates that x goes first and then y, and of course is the point on the line. Quite simply, I put in that x and I see if that y comes out. So I'll write my equation again. Alright, y equals 2x minus 3, and if I put that in my calculator, it'll give me 3. So when x equals 3, y equals 3. So yes, 3, 3 is very much on the line. And as usual, I want you to see that it works. 0, negative 3 is the y-intercept. 1.50, well, it sure looks close enough. And is 3, 3 on the red line? Well, let's go across 3 and up 3, and yes, very much so. It is on that red line. So all the same ideas apply for a parabola. You can see the y-intercept visually, or you can see the x-intercept visually, or you can be asked to find it algebraically. Not usually x-intercepts, unless it's in intercept form, but I'll just show you for the sake of completion, how to find the x-intercept even in vertex form. Okay. Now, the first things first, y-intercept is always easy. Set x equal to 0. So I'm going to rewrite my equation, which is y equals x minus 3 squared. And I put that in my calculator, and it gives me 9. Okay, so the y-intercept is 0, x is 0, and at that time y is 9. Okay, x-intercept, now this is really far too hard for a year 10 question, but I'll just do it for completion. What we do is we set y equal to 0, which is 0 equals x minus 3 squared. And in order to solve that, I'd really see that 0 equals x minus 3, x minus 3. Okay, remember x minus 3 squared is, those two are the same thing. 2 squared is 2 times 2. 4 squared is 4 times 4. X minus 3 squared is x minus 3 times x minus 3. And for any quadratic, we know that we set one side equal to 0. And we solve. And set the other side equal to 0. And solve. And we'll see that for both of these, we'll get x equals 3. Because there's really only one solution. And that is x equals 3. So the x-intercept is actually y equals 0 and x equals 3. Right? Which is 3, 0 if we write it the right way around. Okay, and finally the equation of the line of symmetry. This is quite different from what we do with straight lines, because you don't have a line of symmetry with straight lines. With a parabola, you have a line of symmetry is basically that line there. The line you can draw down the middle of the parabola, right? Remembering a parabola is symmetrical. Now, to find the equation of a line of symmetry, this, by the way, cannot be done algebraically. Okay, or it can, but it's just far too difficult. Okay, so usually it would be asked as a visual question. You'll be given the parabola, and they'll say, "Where's the line of symmetry?" Well, the vertex goes through the line of symmetry. So wherever the vertex is, draw a nice vertical line going up and down. Okay, because it's symmetric. This side is symmetric to this side. Okay, and basically what we do is we write the equation of that line. And all vertical lines have the form x equals, and then there's some number. Okay? And it depends on where does it go through the x-axis, right? So for this particular line of symmetry, the answer is x equals negative 3, right? I have to write negative because it is going through x equals negative 3, right? These are the kinds of questions that you would be asked about critical points in a parabola. So why don't you find the x-intercept and y-intercept of this parabola? Oh, I do notice that the equation is not written, so I'll write it out. The equation is y equals x minus 2, x plus 3. Okay, that's the equation. Find the x-intercept, y-intercept, and the equation of the line of symmetry. Okay, so x-intercept, as usual, we set the x's equal to 0, y equals 0 minus 2, and 0 plus 3. Okay, and we put that in our trusted calculator, and it spits out negative 6. So when x equals 0, y equals negative 6. So if I put that as coordinates, I get 0, negative 6. If I want to find the y-intercepts, this is always very difficult to do algebraically, but you're getting ready for an exam. You should really be ready for this, okay? If I make the y-intercept equal to 0, sorry, if I make y equal to 0, so I get y equals x minus 2x plus 3. Try to fit that in. Okay? Um, I'm just literally rewriting this equation, and where I see a y, I put a 0. Okay? And I get this. Now this is a quadratic, and it's already factorized for me. When a quadratic is already factorized, you set one bracket equal to 0, solve. Set the other bracket equal to 0, and solve. So I get x minus 2 equals 0, and x plus 3 equals 0. And if I solve those two, I get x equals 2. And if I solve the other one, I'll get x equals negative 3. So I get two y-intercepts. When y equals 0, x equals 2. And when y equals 0, x also equals negative 3. If I write those out as coordinates, making sure x goes first, I will get my intercepts. Right. And the equation of the line of symmetry, I said the line of symmetry goes through the vertex. The problem is over here, the vertex isn't clear. Is it negative 0.5, maybe negative 0.6, maybe negative 0.4? We don't really know. What we do know is that it's halfway between the x-intercepts. Right? That value over there, this value over here, is halfway between the two intercepts. Now you can do that in your head. Some people can do that in their head. They say, what's halfway between negative 3 and 2? And they go, okay, I'll go one in both ways. So I get, yeah, I'll go another, go a little bit more. And they'll get that halfway between them is negative 0.5. If you want a simple technique, mathematical technique to find the middle of any two numbers, I don't care if they're positive or negative or both positive. It doesn't matter. Just add them up and divide by 2. I don't care if they're both negative. I don't care if they're both positive. I don't care if one's negative, that always works. Halfway between two numbers, you add them up and you divide by 2. But make sure you do it as a fraction, right? Very important, because if you put negative 2 plus 3 divided by 2 in your calculator, it'll be do 3 divided by 2 first because of bed mass. You don't want that. You want it as a fraction, okay? And if you put that in your calculator, you'll get 1 over 2, which is a half. Okay? So you know that the line of symmetry goes through over here. That is a half. So all vertical lines are x equals number, and in this case it is x equals a half, or 0.5. You can write it any way you see fit.